In this video, I'll be explaining the mod operation to you guys, and I'm going to be showing you how to use the mod operation on positive numbers and also on negative numbers. And it can be a little more tricky with negative numbers, but positive numbers, it's not going to take long to explain. Now, the mod operation can be it's interchangeable with the percent sign, especially in programming languages. So if you're taking a discrete math course for CS, you're going to see this percent sign a lot. And I'll just switch them around in the video so you guys can get comfortable with that. The first problem I'm going to cover is 5 mod 2. And with positive numbers, the mod is interchangeable with remainder, with positive numbers. It's the same exact thing. You can, switch it around. It's the same thing, okay? Now, it gets a little tricky with negative numbers. So if you already know how to calculate the remainder, if you remember how to do that, then you can go ahead and skip over to the mod for negative numbers section of this video. I have timestamps, so you can click on that exact part. But if you don't, this is perfect review for you. So what is the remainder? Well, if you divide 5 by 2, you get a decimal number. But here's the thing about mod. We want only integers. We don't want decimals, okay? We don't want decimals. We don't want, let's say, non-integers. We don't want non-integers, okay? So in order for you to calculate the remainder, well, you can floor this decimal number. So what does flooring mean? Well, flooring for positive numbers just means removing. You just remove the decimal place and only take the integer part, okay? Like, for example, 3.6 floored, right? And this is the floor operation symbol, by the way. 3.6 floored is just 3, all right? What's 5.6 floored? And let's not make a little angle at the top of this bracket. 5.6 floored is 5. So basically all we're doing is truncating it, right? Just removing the decimal part and just keeping the integer part for positive numbers specifically. I'll explain how to do flooring with negative numbers in that section of this video, but for positive number, keep in mind, all you can do is just remove the decimal and only care about the integer. All right, now that we've floored this number, we can multiply it by this guy right here, the second value of mod. So 2 times 2 is 4, right? And 5 minus 4 is just simply 1. And 1 is our mod, our remainder for 5 mod 2. And I know that was a lot of steps, so let's go ahead and cover our tracks again. So what do we do? Well, we divided 5 by 2, right? The left number by the right number in the mod operation. We got the decimal, and then we floored it. Once we floored that number, once we found the floor of 5 divided by 2, all we did was multiply these two numbers together, right? And once we multiplied them, and this x stands for, let's write multiply, because x multiply, because x looks like a variable. So we multiplied the right number by the floored number, right here, to get 4. And all we did was subtract. Let's use different color. Let's use green. All we did was subtract these two numbers together. Subtract to get the remainder. Now, there's another way to do this. I showed you the programming way, okay? That's the way you can do it with a programming language. But there's another way to do this with logic. So there are 3 things you need to keep in mind. Think of a number. So this right here are the 3 bullet points for this number. Think of a number. Okay, this number has to be less than 5, all right? So less than the left number, and this could be some arbitrary variable, let's say x, and x is on the left side of mod, but in this case, I'll write down 5 because that's for the problem. Think of a number that's less than 5, a multiple of 2, which is a multiple of this right number, and also is the closest to 5. Closest to 5. Okay? So we want 3 conditions right here. A number that's less than 5, a number that's a multiple of 2, and a number that's also closest to 5. What number meets these conditions the best? Well, it's actually just 4, right? 4 is less than 5. 4 is also a multiple of 2, and 4 is the closest number. That is less than 5 and a multiple of 2 to 5, right? 2 is technically less than 5 and a multiple of 2. right? But that doesn't work. That number 2 meets the first two conditions, but it doesn't meet the last, right? So you want to think of a number that's less than 5, a multiple of 2, and closest to the number 5, which is 4 in this case. And once you have this number, simply subtract it. There we go. Simply subtract that number by the left number of mod to get 5 minus 4. And that's our remainder, 1. And we got the same answer both times, right? We got 1 both times in both the ways that we did it. So keep in mind, the first way I showed you is more of an analytical approach that you would use if you didn't have the mod operation in a specific programming language. Like, for example, if you're programming in assembly, right, it's not going to have the mod function for you. You're going to have to make that by yourself. So you're going to want to do it that way. All right. But if you're using any other programming language, of course, you can just write down the %, right? It's a lot easier. But the way I showed you here is a more intuitive approach. This would probably be a quicker approach if you get the hang of it, okay? So it's probably an approach that you learned when you were first using remainders. So let's move on to the next problem. So the next problem, let's go ahead and use 7 mod 3. So I'll use the % this time instead of mod. So what's 7 mod 3? Well, let's use the analytical approach. 7 divided by 3 is equal to 2.33 repeated. We can floor this to get just simply 2. Right? Remember, floor for positive numbers, just removing the decimal. And once we have 2, we can multiply 2 by 3 to get 6. And we can subtract 7 from 6. So the left number from 6 to get 1. Therefore, 7 mod 3 is 1. And let's use the intuitive approach. So let's try the intuitive approach. Remember, we have to think of a number that's less than 7, a multiple of 3, and is the closest number to 7. Okay, so what's a number that's less than 7, a multiple of 3, and closest? Well, it's 6, right? 6 is a multiple of 3. It's still less than 7, right? Multiple. And it's the closest multiple of 3 that's less than 7 to 7. Okay, it's the closest, all right? Remember, 3 counts. 3 is still a multiple of 3 and still less than 7, but it's not the closest number to 7. So you need to watch out for that. But once we have this number, all we need to do is subtract 7 from 6, right? The left mod number from 6 to get 1. And that is our remainder. So 1 is our answer for both scenarios, right? You can use both ways. They both work. Let's move on to this problem. For the rest of this video, I'm going to be using the analytical approach because it is more consistent, okay? Because especially with larger numbers, you can't really easily think of a multiple, especially for 103 and 6. So 103 divided by 6, right? If you have a calculator, it should get 17.16 repeated. We can floor this to get just 17. Remember, for positive numbers, you just need to remove the decimal when you floor it. And once we have 17, we should multiply 17 by 6. And 17 times 6 is equal to 102. Right? And once we have that number, 103 minus 102 is just 1. Right? 103 minus 102 is 1. So 103 mod 6 is simply just 1. Let's go ahead and solve this mod. So we have 1023 divided by 13. 1023 divided by 13 is about 78.69. And, you know, this is just a rounded answer, but doesn't matter. We can floor it to get 78, right? When we floor, just remove the decimal. Once we get the number 78, we can do 13 times 78. Right, 13 times 78 to get 1014. And all we need to do last is subtract 1023 from 1014. And this results in a 9. Therefore, our remainder, or our mod for this operation, is just 9. Now, let me show you a fun fact about the mod. The mod can determine divisibility, but it can also determine the parity of a number. Parity, or the even and oddness. If you don't know what parity means, it just means if a number is even or odd, okay? It can determine parity, and you will use this in your Leet code or whatever your CS projects. You use parity, use even or odd numbers quite often, okay? And trust me, I'm literally taking the classes right now, so yes, I know you will use even or odd numbers in your programming projects. But how do you determine if a number is even or odd with mod? Well, let's talk about divisibility first. So if we do 12 divided by 2, we get 6. Okay. 12 divided by 2 is 6. Remember, that's the first step of calculating the mod. If we floor this, we still get 6. If we do 6 times 2, right? 6, the floor number, times 2, we get 12. And 12 minus 12 is just equal to 0. Wait, so 12 mod 2 is 0. Here's the thing. If mod is equal to 0, then numbers are divisible. So that means 12 is divisible by 2. And here's the thing, it is, and we can already know that. We already know that because if we do 12 divided by 2, we get a whole number. We get an integer. All right. So 12, if we do the first step, 12 divided by 2, and we get an integer, it means the numbers are divisible and the remainder is just equal to 0. So if your mod, if you do, 12 mod 2, and this is exactly how you would write it in your programming language, if 12 mod 2 is equal to 0, then the numbers are divisible. And you might actually use that in some of your projects. So keep that in mind. But why does it also determine parity? Well, here's the thing. What's the definition of an even number? Right? What's the definition of an even number? Well, an even number is just any number divisible by 2. And an odd number is just any number that is not divisible by 2. Divisible by 2. Oh, I missed the most important number in the definition. Not divisible by 2. Right? So 12 mod 2 is equal to 0. So an even number is divisible by 2, right? And remember, mod can determine divisibility. So 12 mod 2 is equal to 0. Therefore, 12 is an even number. All right, let's try 13. Is 13 an even or an odd number? Well, we can just take the mod of 2, right? So if you want to determine the parity of a number, you could just take its mod with 2, right? So what's 13 mod 2? 13 mod 2 is 1. And since we have a remainder, since the mod is not equal to 0, 13 is not divisible by 2. Therefore, 13 is an odd number. Let's try 55. 55 mod 2, right? So if you want to determine the parity of a number, take its mod with 2. 55 mod 2 is 1. Therefore, 55 is not divisible by 2. Not divisible by 2. So 55 is an odd number. So, if you take a number with its mod of 2, you can determine the parity of it. This is very helpful. This is very helpful for when you're doing projects. So keep that in mind. Now, we will be doing mods with negative numbers. So, let's go ahead and start this off again. So we have negative 15 divided by 6, right? That's the first step in the analytical method. And we get negative 2.5. What happens if we floor this? Well, if we floor negative 2.5, it's actually negative 3. So truncation means removing the decimal place, okay? And that's what you do for positive numbers. If you want to floor a positive value, just remove the decimal place, okay? But for negative values, it's slightly different. You get negative 3. With your logic, from what I've been explaining this entire video, I'd just be removing the decimal place to get negative 2, but that's not the case, for negative numbers. So let's go ahead and use this little box here that I wrote down. Some of you probably had some questions about that. But let's look at negative 2.5. So negative 2.5 is about here, right? Between negative 2 and between negative 3. And let's say this right here is a building with dirt here. And imaginary story, it's a nuclear bunker because Kim Jong-un might go crazy one day. And negative 2.5 is right here. Guess what happens when you floor it, right? So this is a value of 0. This is the value of 1, right? Along these lines, value of negative 1, value of negative 2, value of negative 3. Flooring sends the value down, right? Flooring, right? If you're flooring something, you're going to the floor, right? The floor is the lowest value. The ceiling is the highest value. There's actually an operation called seal or sealing something, but we're talking about flooring right now, so let's get back on topic. But negative 2.5. When you bring negative 2.5 down to the nearest integer, you actually end up at negative 3. And that's how we get negative 3 here. So let's go ahead and talk. Let's give another example of this. Let's look at negative 5.67. All right. The negative 5.67, remember, you want to bring this value down to the nearest integer. And what value is below, what integer is right below negative 5.67? Negative 6. So if you want to floor negative numbers, you need to bring it down an integer. All right? It's a little different than positive values. But let's continue. Let's remove this nuclear shelter. Let's continue on with the problem. So we have negative 3 now. Remember, what do you do with negative 3? Well, you multiply negative 3 by 6, right? 6 to get negative 18. All right. And what's next? Well, remember, you subtract this with this. All right? So we have negative 15 minus negative 18. And what did we get here? It's 3. Therefore, negative 15 mod 6 is 3. Now here's the interesting thing about this. Mod is always positive. Now, depending on the programming language, it might give you something different, but mathematically speaking, mod is always positive. And you can follow the same approach of flooring, multiplying, and subtracting to find the mod of negative numbers. Let's go ahead and calculate the mod of this. So we have negative 21 divided by 5. This is negative 4.2. And remember, we want to floor this. So remember, flooring for negative numbers doesn't just remove the decimal place, it brings it down in value. Okay? So if we bring this number down to the nearest integer, you get negative 5. All right, let's do negative 5 times 5 to get negative 25. Right? So we got the 5 from here. Right? So negative 5 times 5 to get negative 25. And we do negative 21 minus negative 25. And that gives us 4. Therefore, negative 21 mod 5 is simply 4. And again, this right here is a positive value. All right, so this right here will be the last problem I'll cover in this video. I know, it's been such a nice run. But I just wanted, quick thing I want to mention. It's, oh my god, I'm at 565 subscribers. My goal, high key, was getting 300 subscribers by winter. Guess what I got? I mean 400 subscribers by winter break. All right, I have 500. What? That's absolutely insane. I don't know. I make these videos just for fun. But unfortunately, I haven't been able to make them as much because I've been having a crap ton of homework, like actually a lot. Like some of the labs are ridiculous. But because of that, I get more content. So a couple things I'm looking forward to a lot is making the differential equations playlist, and also making electricity and magnetism playlist. Those would be very fun. I will look forward to doing those, right? I had a lot of fun doing calculus 1, 2, and 3. I also had a lot more fun doing physics and mechanics. The one I'm most looking forward to, if you guys want to study quantum computing, I'm like in the future when I take those classes, and also if I understand quantum mechanics enough, I'll definitely make like a quantum mechanics, quantum computing, quantum information sciences playlists and stuff like that. Those would be very, very fun. But let's actually get back to the problem. I'm not going to take too much of your time because most of you guys are probably here are probably CS majors if you're taking a discrete math course. But this right here divided gives us about 120.47 ... right? We want to floor this. Remember, flooring it brings the value down. So what's a value? What's an integer that's below negative 120.47? It's negative 121. Next, we need to do negative 121 times 17 to get negative 2057. Right? And the last thing, we subtract this guy right here, the guy to the left of mod, from our multiplied value to get 9. So negative 2048 mod 17 is just positive 9. And keep in mind, again, number is positive. It's never negative. But that's it for the video. I hope this helped. And if it did, consider subscribing and liking the video. Thanks for watching.